Hello everyone and welcome from ETHCapeTown. This is another installment of the Blockchain Dev Chat, and I'm here with the man, Rick Moo. You know how much I love what he does. So Richard, would you please tell us a little bit more about yourself for the people that don't know you?
Sure. So I don't know where to start. I guess mostly these days I'm working on Ethers.js, which is kind of like an alternative to like Web3 or Ethereum Lib.js. And the other big project I'm working on, I'm really interested in, is Firefly, which is the open source hardware wallet, air-gapped, all the good stuff.
Yeah. I've heard about a thing that's called Meeseeks.
Oh, Meeseeks, yeah. And Meeseeks is and we're trying to like branch that out. Basically, it's a way to trustlessly use IPFS and still maintain chorus protections that browsers support. So
Ethers is something that is very fond of my heart, and I've always wanted to ask you, like, what are like these the core principles that you wanted to build into this? For example, just to frame you. Something that I've always valued so much in Ethers is that it's very stable. I mean, the API does whatever is there. So what are like things that you have put from yourself into Ethers that makes what Ethers is?
Right. So I mean, realistically, I wrote Ethers in the first place for me. It's something I needed all the time. I found I was always doing the same things over and over again. A lot of boilerplate. So it was basic. Everything that exists there is because at some point in time I needed that functionality. One big difference I would say between Ethers and other libraries that I consider kind of a core thing is to fail early and fail loud. I feel a lot of other libraries, especially in the Ether space, try to guess what you're trying to do and just try to sort of work, but it does result in sometimes destroying money or breaking your contract, or especially a lot of security bugs that crop up in other people's tools because they don't realize that the underlying library is going to make this weird assumption. Like the thing that comes to mind is, I believe Web3 used to automatically detect if a string looked like it was a hexadecimal number. And if it did, it would treat it like binary data as opposed to a string. So things would work fine and good, you're signing data, but you can imagine on a web page you have a text field where you enter some data. It means that you're going to get wildly different results if you enter the string hello world, or somebody decides to like paste 0x like dead beef. All of a sudden 0x dead beef is 4 bytes long as opposed to 10 characters of string. And so it's just like little things like that. I would rather the library fail and die and shut down your application than risk somebody sending Ether to the 0 address when they obviously did not mean to. So
here's where the stability comes from. And another thing that I've noticed is that how small it is. So it's amazing how we were able to do this. I asked you this yesterday, but can you just tell us for the people that are watching this, like how did you accomplish this? Like what are the main things that you did in order to keep this so light and so small?
Right. So again, we talked about this yesterday, but to give a quick overview, there's a lot of different places. One thing is to chop out a lot of cached data that's not necessarily needed to be cached, that a lot of other libraries include. There's a lot of scripts that go through and kind of pull out unused dead pieces of code. A big difference between this and, again, other libraries is a lot of other libraries have a big decimal JS as well as big integer JS as well as BN.js. So you've got 3 80 kilobyte libraries that are all designed for handling numbers. And each one is not really used for everything. The key takeaway, I guess, for Ethers is it supports signing. So it has elliptic.js in it, which is a phenomenal library. Highly recommend it for elliptic curves. And it includes BN.js. So you have to have BN.js no matter what. So rather than including other libraries, just kind of use BN.js for all your other big number needs, and
just stick with it.
Exactly. Like, stick with what you need, and then do not have dependencies. That's a huge killer, right? Once you start pulling in other weird dependencies, well, they have dependencies upon dependencies upon dependencies.
Exactly.
And even though there's functionality in there you don't use, you're pulling along this extra stuff just because of other stuff that's other stuff. And there's basically small size was a big deal for me. I wanted early on, especially that to be to be a key focus.
Very light.
So yes, I try to keep it very light. One other quick thing I'd mention as well, that's an important thing for me, is licensing. Licensing drives me nuts. I am a big fan of open source, and by open source I mean like MIT, BSD. A lot of the other libraries, especially the time, were GPL or LGPL, or they're usable, but they put weird restrictions on the types of projects and the types of people that can use these things. When it's MIT or BSD licensed, you can just kind of use it. It doesn't matter if you're a proprietary entity. You can, So.
Absolutely. Okay, I'm going to ask you one last question. It's my $1 million question,
Sure.
And it's like, what in your opinion is like a concept or a tool that is very cool, very powerful, but is like either not enough developers know about it or is very underrated? What's like this thing in your mind?
And this is like, when people ask me this, it's always the same answer, like ENS. ENS is by far the most important, and I always go on like, if ENS was the only thing that came out of Ethereum, I would consider Ethereum to have been a wild success. Like, it solves so many of the problems that we face in the world today, not even just in the blockchain world. As a quick overview of some of the things I often complain about, and I could go on for hours with this, so I'll keep it short. But for example, the way that SSL certificates work. Right now, there's a whole bunch of CAs who give out certificates. If any one of 2,000-ish, I don't know how many there are, but there's over 1,000. If any one of them lies, the security of the entire system can be compromised. That is insane to me. So the things like ENS allow you to have self-signed certs that are actually more secure than trusting CAs. You can store, just even in terms of usability, being able to go to send Ether to rickmoo.firefly.eth and have it go. The best way I can describe to people how important ENS is I challenge anyone for the day to go into their settings in system preferences or control panel if you're using Windows and deactivate your DNS. See how useful your computer is for a day with no DNS. It is
like when
absurd.
typing like 167
Absolutely.
or something.
You better have memorized your Google domain. Well, most things won't even work because of vhosts. Like it's So absolutely, ENS is by far the most important thing. You can do so many crazy awesome things with it. And it's even, I feel, more robust than DNS because it's really key value stores. One of the really cool things you can do with ENS is you can have the owner of an ENS name being a contract, which can then give out names under itself, and you can do really wild, crazy things. Like having a living DNS system that's hierarchical. I mean,
becoming
DNS
a graph like a tree almost.
Exactly.
Yeah.
But it's a tree that can manage itself according to like strict rules or loose rules. You get to decide the level of what magic you want to be present in. So
all right. Thank you very much for the time that you have spent with us, and it's been my pleasure.
Awesome. Thanks.
Thank you. See
Thanks
ya.
a lot.